Hi guys, this video is all about transducers. Now transducers, let's understand what is transducers. Transducer is one which converts one form of energy into another. Whatever we see, whatever we hear, whatever we smell, and even the emotional aspects are all coded in terms of electrical energy by transducers. These impulses are then taken to brain, our gray matter, where they are decoded and respective responses are sent to respective organs. For example, if I take a rose and smell it, olfactory nerves, transducers converts it into electrical impulse, sends it through, so it is coded in form of electrical impulse, sends it to brain. There again transducer decodes it, and then the response, rose, it smells good. So that's what, all because of transducer. If transducer wouldn't have converted this smell into electrical impulse, brain wouldn't have decoded it. Again, even in brain, transducers decodes it. So the world wouldn't have been the world that we see, that we hear, that we enjoy if transducers wouldn't have been there. So how significant is transducers? So let's try and understand more about it. Here in this video, I would be dealing with hearing, seeing and smelling. Alright, to begin with, let's get into the mode of seeing. When we talk about seeing, basically it's all about the object. Object throws the incident light to our eyes, which goes to retina, and we see it. Before getting into actual process of seeing involving transducers, let's be prepared for it. And for this preparation, it is Manthan who's going to help us understand light, wavelength, period, frequency, energy, the relationships, and then I would apply it to our dear transducers and then carry on further. Okay, let's see what Manthan has to say.
Hi guys, I am Manthan. Today I will be explaining light in terms of wave. As we know, one crest and one trough makes one wave. The length of a wave is expressed in lambda and the time taken to complete one wave is expressed in time period t. As we know, the formula for frequency is number of waves travelled per second time. So as we compare the first wave to the second wave, we can see that in the given distance, only one lambda is covered in the first wave. But when we see the second wave, we can see two lambdas are covered in the same distance. So from this we can conclude that the frequency of the second wave is higher than that of the first wave. And the reason is the wavelength of the second wave is much lesser than the first wave. So coming to the formula for energy, we can see that formula for energy is h nu, and where nu stands for c over lambda. From this formula we can conclude that energy is inversely proportional to lambda, that is wavelength. As we come back to the second wave, we can clearly see that the frequency here is greater than that to the first one and the wavelength is less, due to which the second wave will have higher energy compared to the first one. In order to understand the link between energy and wavelength, we have created a mnemonic which presumably will be helpful to you all. It is given by gamma x Vectra, in which gamma stands for gamma rays, x stands for x rays, u stands for UV rays, v stands for visible rays, I stands for infrared rays, m stands for microwave, and Ra stands for radio waves. The wavelength increases from gamma rays to radio waves, while the energy decreases from gamma rays to radio waves from the given formula, in which E is inversely proportional to lambda. As we come to visible light, we have conventionally studied about Vidyar, in which V stands for violet, I stands for indigo, blue stands for blue, green, yellow, orange and red. As violet is close to gamma rays, it has lower wavelength and higher energy, while red, which is close to radio wave, has lower wavelength, lower energy and higher wavelength. As we come to the third wave, we can here see that we have increased the amplitude while keeping the frequency intact as compared to the first wave, due to which the intensity increases. From the formula, intensity is directly proportional to amplitude square. As we come to the fourth wave, here we can see that we have increased the amplitude as well as the frequency, due to which the intensity increases and as a result power increases. And due to the increased frequency, we can see that the energy has increased as well. So in this wave, we can see that it has more power and more energy as compared to the first, second and third wave. Application for all this will be carried on further by Ankur. For now, Sahil has to say something on work, power and energy. So over to him.
Thank you, Manthan. Hello guys, myself Sahil. I am going to talk about energy, work and power in terms of light. As we all know, the formula for energy is h nu, which is also equal to hc over lambda, where h is Planck constant and the value for h is this, and c is velocity of light and value for c is this, where h and c are constant. Energy is inversely proportional to wavelength, which implies lower the wavelength, higher the energy. Now coming towards work, there are two types of work. Linear work and rotational work. The formula for linear work is force into displacement, and formula for rotational work is torque into angle theta. Torque is also denoted by tau, and theta T is being provided by photons h nu, creating angular displacement theta, which concludes h nu, higher the h nu implies lower the lambda and higher the energy as mentioned here. Now work is equal to tau into theta, where work is directly proportional to theta, so lower the theta, lower the work. Now coming to power, the formula for power is work upon time. Therefore, faster coverage of theta implies less time required and more power gain. Now coming to power, the formula for power is work upon time. Therefore, faster coverage of theta implies less time required and more power gain, and vice versa. Over to Ankur.
This is what is Levin's retinal, which is present in rods of retina and responsible for viewing. Alright. Now as soon as photon strikes Levin's retinal, now if you observe over here, both the groups are on the same side of double bond. So it's cis isomer. Configuration is cis. Now as soon as photon strikes, this cis configuration changes to trans configuration. Now if you check it out over here, now see this group which was here has moved up. Now I have shown it over here. Now see, this was initial position of the group, and then on absorption of light, it has changed this way, right? That's depicted in red. So the group has moved via angle theta. Theta is angle by which the group deviated for changing configuration from cis to trans. We saw how photon deviates the group via angle theta. What is interesting is, how do we differentiate one item from other? Rather, I would say that flowers from person from building, or colors of flowers to be specific. How do we differentiate? It's the same stimulus by all these items. Then how do transducer do it? Obviously, transducers have to generate different responses in terms of electrical response for different items, for different species that we are seeing. Now, obviously, otherwise, if transducer doesn't do that, then what we see is one and the same thing. Everything, even if we look at a person, we would find it's a flower, or if we see a flower, we would find it's a person, and so on and so forth. So differentiation is very much essential. So it's all transducer's job. So definitely transducer generates different electrical response for different items. The thought comes to me is, what is responsible for all this? So two parameters that come to my mind for generation of different electrical impulse. The one is When the photon energy is very high, it covers up this theta rapidly, and when the energy of photon is low, it covers up this theta slowly. So this rapidity with which it covers generates different electrical impulse, thus differentiating one impulse from other and helping us differentiating what we are seeing. And second thought that comes to me, when there is less energy of photon, maybe it does not pick up the entire theta, thus generating less electrical impulse. When the energy of photon is high, at that time it maybe covers up the required theta and hence generates high electrical impulse. So this electrical impulse, thus in this way, electrical impulses are different for different stimulus and thus helps us in differentiating what we see. Let me try and make you understand the phenomena that I was trying to explain about theta. Alright, now suppose this was the cis form, right? Now as light comes on it, it gets converted to transform. So cis form getting converted into transform. When photon of lower energy is irradiated, what happens is it covers theta at a very slow rate. So work upon time, that is power, rate of doing work is very low, very slow, very low. So transducer codes this work into very low electrical response. But when the photon irradiated is of high energy, that is lower wavelength, then it covers that theta very fast. Now since it covers that theta very fast, so the rate of doing work is very high, so the power is high, so transducer codes this stimulus in very high electrical response. That is how I feel all these stimulus are coded by transducers. Varieties of stimulus are responsible for generating varieties of responses, owing to which we are able to differentiate all the items that we see, all the colors that we see, all the specimens that we see, and everything whatever we see are able to discriminate only because of these relationship between stimulus and response. All right. Other concept that I had in mind was not covering full theta. Now when photons of less energy strike the molecule retinal, then the cis form does not cover up the entire theta. It just covers up slight angle. All right. And when it is struck by photon of high energy, then it actually covers the entire theta. As a result of which this theta, this theta, this theta, this theta, this theta, all these thetas generate different electrical impulse. All right. Now since it does so we are able to discriminate what we see. Hope you enjoyed the video. More to come about transducers working hard on olfactory nerves, on auditory nerves, all right, in my coming video. And let's see how it goes. Keep viewing. See you.